Good afternoon. My name is Rosemary with the Access Board, Washington, D.C. The public meeting will begin momentarily. Do note, this meeting is being recorded. Captions are available by clicking this closed caption icon in the Zoom toolbar below. American Sign Language is also provided. Presentation materials are available in the news article on the board's news page at www.access-board.gov/news. I will repeat this information in another 30 seconds, so please stand by. Good afternoon. Good afternoon. My name is Rosemary with the Access Board, Washington, D.C. The public information meeting will begin momentarily. Do note, this meeting is being recorded. Captions are available by clicking the CC icon in the Zoom toolbar below. American Sign Language is also provided. Presentation materials are available in the news article on the board's news webpage at www.access-board.gov/news. Ladies and gentlemen, I give you Sachin Pavitran, Executive Director.
Please, go ahead.
Thank you, Rosemary. Good afternoon, everyone. I'm Sachin Pavitran, the Executive Director. My pronouns are he, him, his. I want to welcome you to this afternoon's informational meeting on low height specification for medical diagnostic equipment. As you all are aware that we've been working on the medical diagnostic equipment for some time. We finalized the rule in 2017, but this one provision was still pending due to limited data to finalize this particular provision. I want to thank the team at the Access Board who's been diligently working on this issue, but also want to acknowledge Dr. Souza, who you'll be hearing from this afternoon, for his work and contribution to our rule. With this, I want to transfer the time over to my colleague, Bobby Stinnett, who is going to moderate the discussion today and also who has been the lead person on this particular topic on staff. Bobby, the time is yours.
And thank you, Sachin. And hello, everyone. As Sachin said, my name is Bobby Stinnett. I'm an accessibility specialist here at the U.S. Access Board. And my pronouns are he and him. Just to describe myself, I'm an African-American male. I have a bald head. I'm wearing glasses. I'm wearing a blue blazer, a red tie, and a white button-down shirt. And as Sachin said, I also will serve as today's moderator for this informational meeting on the low transfer surface height for medical diagnostic equipment. Okay, so let's go ahead and we're going to pull up the slideshow and we're going to move forward with just talking a little bit about giving a small brief background related to medical diagnostic equipment. So as we note here on the slide, Section 510 of the Rehabilitation Act that gave the Access Board the responsibility of developing and maintaining accessibility standards for diagnostic equipment. Now, when we talk about medical diagnostic equipment, it's equipment that's used by healthcare providers in more of like a healthcare medical type setting. And that's what Section 510 of the Rehabilitation Act gave the Access Board the authority to do. Then with that authority in 2017, in January, to be the month was January, the Access Board did issue the medical diagnostic equipment standard. Now you'll hear me say MDE for short, but medical diagnostic equipment, or MDE. What that did in 2017, we established the minimum technical criteria for various type of equipment. And that equipment that we're talking about is used in various medical settings, like we note here on the slide, like physicians' offices, rehabilitation centers, hospitals, and then other different types of medical settings. And an important part about this piece, it's really about that independent access. So people with disabilities are able to use to be able to access the diagnostic equipment, as an individual and on their own way, and not have to have support in doing that. And so it's about that independent access is what's really important here to note. Okay, so let's move on to the next slide, slide number 6. And let's talk a little bit more about some of the other specifications that the medical diagnostic equipment standard addressed. And so some of the other pieces that it addressed was kind of the height and the adjustability of various types of medical diagnostic equipment. And what also is important to note here is that it's about how people transfer on and off of the equipment. And it could be, when we talk about the different types of equipment, it could be examination tables, examination surfaces, different types of, let's say, a dental chair. It could be mammography equipment, so imaging equipment with tables, any type of equipment. Those kind of fall under what the MDE standard actually supports. Okay, so let's move on, and let's move on to slide number 7. And we're going to talk a little bit about the rulemaking on medical diagnostic equipment standards. So in December, as we note here on the slide, in December 2010, there was a report done, a study done. It was the Anthropometry of Wheeled Mobility Project, and that was done in 2010. Now, the thing about that project is that it really collected a lot of anthropometric data on various people who use wheelchairs, mobile, in various weights. And it also, the researchers also measured like wheelchair seat height, and they looked at also reach ranges and then other dimensions as well. Now, that study, some of the findings from that study, it talked about that the occupied seat heights for people who use wheeled mobility devices, it varied considerably. And particularly some of like the seat ranges for manual wheelchairs, for power wheelchairs, and for scooter users, it was really based on that data that was received, the various data. The researchers concluded that a transfer surface that is adjustable from a height of 17 inches minimum to 25 inches maximum would accommodate the 5th to 95th percentile range of those who use wheeled mobility aids. Okay, so let's move on to the next slide, and let's talk a little further about where we are in terms of the notice of proposed rulemaking for medical diagnostic equipment standards. So in February 2012, just kind of give you a timeline of how everything was in place. So in February 2012, the Access Board, we sought public comment on whether that transfer surface should be adjustable, like I said, within that range of 17 to 25 inches maximum. And that same year, the Access Board, looking at that data, the Access Board actually organized an advisory committee representative of various stakeholders to provide comments and provide recommendations on how the medical diagnostic equipment standards basically should be finalized, and using also kind of the public comments as well to determine what the high reach should be and what the low range should be. So what was kind of important to note is that most commenters supported the requirement really for kind of that adjustability and kind of that high transfer height of 25 inches, but there wasn't a consensus on kind of that low transfer height and what that should be. And really the public comments and the advisory, they were really divided on that issue. Okay, so let's move on to the next slide. And so let's talk a little bit about where we are right now related to medical diagnostic equipment and the final rule. As I mentioned earlier, in January of 2017, the Access Board issued a final rule for medical diagnostic equipment. Now, in that final rule, the Access Board said that the transfer surfaces to be adjustable from a low transfer position at a height of 17 to 19 inches to a high transfer position at a height of 25 inches. Now, it also required that the transfer surfaces that they be adjustable also to four kind of 1 inch unspecified heights between the high and low. So it's really that unspecified height between the high and low area as well. Now, really that approach was really taken because of the insufficient information on what that low transfer height really should be. Like I said before, some of the advisory committees and the public comment, it wasn't a consensus on what that low height should be. And so this year in February, the board issued a direct final rule to extend we had a sunset provision, and we extended that provision until 2025, January 10th to be exact, to provide additional time to complete research on that low height transfer piece and for final specifications to determine what that low transfer height really should be. And that's really where we stand right now. Let's go to the next slide, slide number 10. And let's talk about some of the research that the Access Board conducted to try to address this question. So in 2021, last year, the Access Board did commission a secondary analysis of the Anthropometry of wheel mobility database that I spoke about earlier. And specifically, as we note here on the slides, that was really taken because many segments of the population of the test sample that were used were either over or underrepresented. And also, researchers did statistically resample the data. And specifically, one area was that the test population was younger in age, and then it included more men than women compared to the estimated US population. Now, in addition, the researchers intentionally oversampled the powered wheelchair users, which tend to have seat heights higher than manual wheelchairs, in order to capture the sizes and space requirements of this group. Now, researchers, what they did was statistically resample data on the occupied seat heights for manual and powered wheelchair users, and then to create virtual samples. Now, what they did is that representative sample, they did it for the total population of wheelchair users in the United States. And they did that in terms of kind of the device type. So it could be a manual wheelchair or a power wheelchair. They did it according to gender and age category. And I think that report is what we have our presenter, Dr. De Souza, who's going to talk a little bit about the findings. So let's move on to the next slide. Okay, and so let me introduce to you Dr. Clive De Souza. So Dr. Clive De Souza is a human factors engineer and researcher in the Department of Rehabilitation, Science, and Technology at the University of Pittsburgh. Dr. De Souza has a PhD in industrial engineering and a Master's of Science degree in mechanical engineering from the University of Buffalo, SUNY. His research focuses on human performance measurement and human system integration related to disability and aging, accessible and inclusive transportation design, and occupational health and safety. He was previously an assistant professor in the Department of Industrial and Operations Engineer at the University of Michigan in Ann Arbor, and core faculty at the U of M Center for Ergonomics and Center for Disability Health and Wellness. And Dr. Souza, we're happy to have you here to discuss the findings from the analysis of the low wheelchair seat heights and transfer surfaces for medical diagnostic equipment. Dr. Clive De Souza, I'll pass it on to you.
Bobby, thank you for the presentation, for your introduction. Much appreciated. I will, over the next few minutes, discuss some of the work that we did as part of this study. I also want to thank the board, firstly, for just giving me the chance to present to all of you our findings, and hopefully it helps inform some of the questions that all of you are grappling with regarding low seat height for transfer surfaces. Okay, so trying to make sure that my goals work. You should have another slide in between here. But the agenda for today is that I'm going to talk a little bit about the Anthropometry of Wheeled Mobility project, just as a background, what the study was about, and then what the goals of the study were, which I'm showing you on this slide. The Anthropometry of Wheeled Mobility project started out under the directorship of Dr. Edward Steinfeld at the University of Buffalo, Center for Inclusive Design and Environmental Access. At the time, I was a graduate student there, and I've been working with the Idea Center on the same data set during my time at Michigan and then now at Pittsburgh. The project originally had 4 goals, broadly stated. First, to develop reliable, accurate methods for measuring the anthropometry of wheel mobility users. By that, I mean body size, shape, as well as the device size. And then using those methods to collect anthropometric data on a large sample of wheel mobility users. Originally, the standards that have been developed for accessibility were based largely on manual wheelchair users. And so one intentional focus of this study was to obtain information and data on newer wheel mobility devices, such as power chairs and scooters, so we could better understand the capabilities and space requirements of these devices, as well as the capabilities of the occupants that use them. Thirdly, we wanted to combine all of this information on manual powered wheelchairs and scooters into a database so that it could serve as a foundation for a long-range research program. One aspect of that long-range research was to develop design tools and design guidelines and recommendations that could be used for technical assistance, standards development, and design. This last point relates directly to the objective of today's presentation, and you will see shortly how we've been using this data to actually inform and guide standards development. This slide shows you a couple of images of just what the data collection methods were. We used a 3-dimensional electromechanical probe, so to record locations of specific points on the body, as well as on the wheelchair of our study participants. The image on the left is showing you an example of how we were measuring dimensions on the body of different wheelchair occupants. The image on the right is an example of how we measure reach ranges. So we had our study participants reach to different locations at different shelf heights, and we could measure how far they could reach. This is just an example of the types of data that we have in our database. Our study sample consisted of 500 wheel mobility device users At the time that we wrote our final project report in 2010, we only had 495 users, and hence you'll see that slight difference in the sample size. Subsequently, we had 5 more, and so we have a total of 500. We have 53% men, 47% women in our sample. In terms of device type, 55% of the participant used a manual wheelchair, 38% used a power chair, and 7% used a scooter. All of our study participants used a wheel mobility device as the primary means of their mobility. We intentionally try to recruit individuals with a diverse range of functional abilities, and so they represented individuals with different types of mobility, medical conditions such as spinal cord injuries, cerebral palsy, multiple sclerosis, stroke, and amputations. Our study sampling occurred primarily in 3 locations. So one was in the greater Buffalo area in New York. The second was in Ithaca, New York, and third in Pittsburgh, Pennsylvania. With regards to today's presentation, here are some examples of how our data could be used to inform the design of accessible medical diagnostic equipment. So for one example, we could use dimensions of occupied length and width of our study participants to develop sizing recommendations for clear floor space, such as on wheelchair accessible weighing scales. We have information about knee heights and toe clearance heights, and some of that information can be used to determine space requirements beneath equipment for knee toe clearances. And lastly, I'll be talking about today in the context of occupied seat height. This is the compressed seat height of the wheelchairs used by individuals in our sample, and how that could be used to inform the heights for seated transfers. Initially, we had done an analysis in a previous report on just the occupied seat height. So this graph shows you box plots showing you the variability in seat heights of the individuals in our sample. I have intentionally only shown manual and powered wheelchair users here. And so it's data from 466 individuals, and I've excluded scooter users. The image panel on the left shows you the seat height distribution for users of manual wheelchairs. The image panel on the right shows seat height distributions for individuals using a powered wheelchair. I've also stratified this data by men and women, and young and old. If we look at the image on the left, overall, we can see that manual wheelchair users tend to have a seat height that is an occupied seat height that is generally lower than powered wheelchair devices. It's also interesting to note there is a large variability even within each of these 8 subgroups. And that variability is depicted by the length of these tails on the box plot. So the longer the tails, more diverse is that subgroup. So we're seeing this large diversity across even within each of these 8 subgroups that I've depicted here. These data are based on our original sample, so based on the actual users that we measured. One of the concerns or sticking points from that analysis was the lack of representation or the proportional distribution of our sample relative to a national sample. So I'm showing you over here the percentages in our sample relative to the national sample, so we could make that comparison and get a better understanding of where we have over versus under sampled in our study. There are numerous national databases that we could refer to in terms of the proportion and number of wheel mobility users in the country. However, most of these studies combine powered devices together, meaning they have combined proportions of percentages of powered and scooter devices together. If we are interested in only looking at manual and powered and not scooter devices, then we have to go back to a study that was done in 1994 to 97 by the National health interview survey, which is the disability component of that survey, which actually shows percentages of manual and powered separately along with gender and age. The table on the right shows percentages from our Idea Center study sample. You can think of this as the original proportions of our data set. The table on the right shows you the proportions from this national sample from the 94-97 study. And you can think of this as the target. This is what we would have ideally liked to achieve in a study sample. There are lots of numbers on this slide. And so I would draw your attention just to the bottom row, which is showing you the total percentage of manual versus powered for both our study and the national sample. Particularly, I draw your attention to two numbers. If you look at the proportion of powered wheelchair users in our sample, it was 40.6%. Again, this is only manual and powered. I've excluded scooter users. So we had 60%, about 60% manual, 40% powered. If you look at the national sample proportions, manual wheelchair users made up close to 91%, powered wheelchair users made close to 8.8%, almost a 90% to 10% ratio. So it's very clear that in our sample, we have a larger proportion of power chair users. This was totally by design, it was intentional, because we wanted to get a better understanding of the abilities and space requirements of this particular subpopulation. So when we present our summary results from our study, it is a fair point that our study has a larger number of powered wheelchair users than what one would have expected in a national sample. So how do we address this problem when we are doing any type of analysis? That's where our resampling methodology comes in. I'll give you a quick overview of how we accomplish this. So if you imagine that we had our original Idea Center study sample of 466 users, we split up this sample into 8 subgroups. 8 subgroups split by gender, so men, women, device type, manual and powered, and then age groups, we had a younger versus an older cohort. So we split this into 8 subgroups. The next step, we perform random selections with replacement from each of these subgroups, and we select them to obtain a virtual or a synthetic sample that will now have proportions that match our target or that national survey that I had showed you on the previous slide. So here's one example. We randomly selected 500 users from our current sample with replacement in such a way that these 500 individuals now in this virtual or synthetic sample have proportions exactly matching our target distribution. We do this once, we do this twice, we do it 3 times. So in a sense, we do it, at least for our analysis, we repeated this 100 times, each time producing a sample of 500 with the exact target proportions. We can compute the summary statistics for each of these. For example, the mean, the standard deviations, the percentiles, and then we compute the average across all of those 100. So in a sense, we are computing the mean of all the means, and statistically, that would be more representative of the actual or true population mean. This next slide shows you the results from our analysis, and I will walk you through this image. This is showing you a percentile plot of 3 different populations. We've got the curve on the top left corner, which is comprising of 100% or entirely composed of manual wheelchair users. And on the bottom right corner, the green curve is showing you 100% or all powered wheelchair users. The x-axis or the horizontal axis is showing you seat height in inches, in 1-inch increments, going all the way from 17 to 26. The vertical axis is showing you percentile, going from 0 to 100%. What do we mean by percentile? By percentile, we mean the proportion of users that have a seat height equal to or less than a particular seat height given in inches. So for example, this curve in the solid black line is our proportionally represented or weighted sample, where the individuals are weighted based on the national target sample. If we draw a vertical line at 19 inches seat height, gives us a percentile of 42%. This means that 42% of our weighted sample have a seat height equal to or less than 19 inches. Likewise, at 18 inches, we get a percentile of 21. This means that 21% of our weighted sample have a seat height equal to or less than 18 inches. Likewise, at 17 inches, 4.5% of our weighted sample have a seat height equal to or less than this value of 17 inches. These numbers are critical because these would be the percentages of people in a wheelchair that we estimate would be excluded from a design that has a lower seat height set at this value. Individuals that have a seat height higher than this value would be accommodated, or in a sense would be able to match their seat height to the transfer surface, given that the transfer surface has an adjustable seat height. So again, these three numbers are critical because these would be the number of people potentially excluded by our design at 17, 18, and 19 inches respectively. One point of note in this slide is that our weighted sample was based on proportions from the study done in 94, 96, 97, right? So that was almost a couple of decades back when we had few power chair users in the national sample. I will advance my slide. Let's see. Okay. So one of the nice attributes of using a resampling strategy or procedure is that we can explore different scenarios or different changes in population demographics. For example, one could ask the question, what if the percentage of powered wheelchair users compared to 1994-97 has now increased? What if it has increased by 10%? Or what if it has increased by 20%? Well, we can conduct these kinds of what-if analyses using a resampling methodology. So what I'm showing you here are three sets of values. So basically three subtables. Again, I would draw your attention to the total row. So the row at the very bottom as a start. On the left is our table from the original 1994-97 proportions. We had 8.8% power wheelchair users in that national survey. Table in the middle is a hypothetical scenario where we have increased the proportion of power wheelchair users by 10%. So from 8.8 to 18.8%. Likewise, in the table on the right, we have increased it by a further 10%. So basically 20% from the original national survey to give us 28.8% power wheelchair users. And of course, in these examples, the increase in power chair use is coming at the cost of a decrease in the proportion of manual wheelchair users. So we still have a total of 100%. In the we can rerun our same analysis using our resampling methodology for each of these three scenarios and compare the results of a potential or hypothetical increase in power wheelchair percentages. That's what I'm depicting on this slide. So this is the same slide that I showed you a few minutes back. What we've done is we've added two other hypothetical scenarios. So the solid black line, again, shows you the distribution of the percentiles for our weighted sample from the 1994-97 study. The gray line next to it shows you a 10% increase in power chair usage. And the light gray line to the right of these curves shows you a 20% increase in power wheelchair usage. So what we are seeing here is that if we compare these three curves, so these three curves to the 100% manual wheelchair users shown in dotted blue and the 100% power wheelchair user curve in dotted green, as the percentage of power wheelchair users increases, this distribution starts moving towards the curve for power wheelchair users. And it is moving away from the line for manual wheelchair users. So in a general sense, intuitively, that hopefully is clear to everyone. Let's look at the percentage included versus excluded across these three different scenarios. If our lower seat, transfer seat height was set at 19 inches, with our original proportions from the 1994-97 study, we estimated that 42% would be excluded. If we increase the power wheelchair usage by 10%, so we go from 8.8 to 18%, the proportion of people excluded decreases from 42 to 39%. Likewise, if power wheelchair users increase to a further 10%, so 20% from our original, the percent excluded drops even further from 39 to 36%. So with every 10% increase in power wheelchair usage, we are seeing a smaller and smaller number of people that will be excluded by our design. That change or net benefit in terms of increasing power wheelchair usage, that change is greater at 19 inches, less so at 18 inches seat height, and it is almost negligible at the 17 inches seat height. So what this tells us is that as the power wheelchair use percentage increases in our national sample, we might see greater changes in percent accommodated at 19 and 18 inches. However, a seat height of a lower seat limit of 17 inches would show minimal to no change. So it would be more robust in terms of a design and be less susceptible to any future changes in wheelchair demographics. So that's really the key, I think, aspect of this analysis, is the ability to investigate these kinds of hypothetical scenarios. So I'm on my last slide in terms of the conclusions of the study. What I've hopefully tried to do over the last few minutes is give all of you an understanding of what we mean by statistical resampling and how we use that procedure to generate proportionally representative samples based on using our original study sample to match our target percentages. We use this resampling methodology to estimate the proportion of wheelchair users with seat heights equal to or less than 17, 18, and 19 inches. Again, for my presentation, I focused primarily on these seat heights because we were interested in really honing in on that lower seat height limit. Some key findings with regards to this. We noted that if the lower height limit of medical diagnostic equipment transfer surfaces was set to 17 inches, then the proportion of wheelchair users excluded is estimated to be no more than 4.5%. If it's 18 inches, it would be no more than 21%. 19 inches would be no more than 42%, respectively. Due to the small proportion of powered wheelchair users in the 1994-97 national survey, percentiles for the combined proportional sample were generally tracking or following the same distribution as manual wheelchair users, because manual wheelchair users made up 90% of most of the national sample. And so our weighted sample was very similar to the sample of just manual wheelchair users. Which brings us to our next point. We could use statistical resampling to estimate the potential influence of increasing powered wheelchair user proportions. We noted that based on our analysis and our original study sample, at 19 inches seat height, a 10% increase in powered wheelchair users decreased the percent excluded from 42 to 39%, which is a good thing. At 17 inches, a 10% increase in powered wheelchair users decreased the percent excluded from 4.5 to 4%. So we saw a marginal improvement in terms of percent accommodated. This analysis also points to the fact that setting design specifications near the lower end of that distribution. So for example, 17 or 17.5 inches would be less effective or more robust to any future changes in population demographics. In my presentation that is available to all of you, I've provided links to two reports. One is the report on which this presentation is based. It was the analysis of low wheelchair seat heights. This is on the Access Board's website. I've also provided a link here to the final report of the Anthropometry of Wheeled Mobility project that was developed in 2010. And so both links are available here. I would like to acknowledge some of the sponsors of this work. The original study for the Anthropometry of Wheeled Mobility project was funded both by NIDLR, the National Institute on Disability, Independent Living and Rehabilitation Research, as well as the US Access Board. And a lot of the original study, the concept of the study, and the data collection and analysis was done at the Idea Center. And I also would like to acknowledge their support for some of the work that I've done. This is my contact information, my email address, as well as my phone, in case any of you have follow-up questions or additional analyses that could be done leveraging this existing database on the Anthropometry of Wheeled Mobility users. Thank you all for your time and attention.
And thank you, Dr. Souza, for your presentation today. So let's going forward. If you have any questions about the study, just make sure you can type those in to the Q&A in that area, and then we can we'll go from there, okay? But Dr. Souza, we do already have a question for you. Let me pull up the question here. So the first question is, nationwide, what is the breakout for mobility devices? Like, what % of the population uses manual and what % uses power?
So recent estimates that I've seen, I think we're about 3.5 to 3.7% of the civilian non-institutionalized population that uses, so community living, individuals living in the community that use wheelchairs. The breakdown between manual and powered devices, as I was mentioning earlier, is a little bit more tricky because the powered devices in the recent surveys combine all powered devices. So that would be powered wheelchairs as well as scooters. And so they're all grouped into one category, and which is what makes, I think, comparisons to this study a little bit, I think, challenging. To get that breakdown between manual and powered wheelchairs specifically, we had to go back to that 1994-97 study.
All right, thank you for that. So looking here, it looks like there's no other questions we have concerning the study, but what we can, first of all, thank you again, Dr. Souza, for your presentation today. So what we're gonna do now is we're gonna go ahead and move on to the public comment area. And before we get to the public comment area, I want to talk a little bit about what the Access Board is particularly interested in gaining from this informational meeting. Now, what's important, also want to kind of clarify that when we talk about this information, we want to clarify that the standards, the MDE standards, include many different provisions. But today we're only focusing on the low transfer height and to work towards finalizing that provision, which is set to sunset in 3 years. Okay, so that's where the focus of today's informational meeting is today. And in addition to that, what we're requesting and hoping to gain information today about what's the low height of adjustable medical diagnostic equipment products that are currently on the market. So any information about what's currently out there, MDE products that are currently available. And then in addition to that, what changes or innovations in the design and engineering of medical diagnostic equipment that may have occurred since the board issued the standards in 2017. So any changes or innovations, that will be an important information for us to learn as well. And then also any updated information on the incremental cost for the design or the redesign and manufacture of medical diagnostic equipment that can provide a low transfer height of 17 inches. So that's kind of what we're looking for to kind of gain information in this informational meeting. And we're going to go ahead and open this up to public comment. And so let's just talk about how to be able to submit public comments, okay? So in order to do a public comment, you can request to speak using your Zoom's Q&A feature. Just list your name and your organization, the topic of comment, then I will enter you into the queue, or you'll be entered into the queue, and me, the moderator, I'll announce when you should unmute. If you're doing it by phone, that's *6. And then the moderator will also announce next in queue. If you need ASL, please note that in your request and note that in your comment. And also, please limit your comments to under 3 minutes. Okay? All right, so what we're going to do is move forward. And we're going to first start off with some of the comments, the commenters who signed up already to speak, and we'll start with them. So let me go to the first one. And we have Mike Thomas. If Mike Thomas is available, you're allowed, you can go ahead and speak.
Hello. Yes, can you hear me okay?
We can hear you great.
Okay. All right. I just wanted to mention that I also put something in the chat and it didn't seem to get read, but we can worry about that later. I'll go ahead with my comments. Good afternoon. My name is Mike Thomas. I'm the Director of Product Management for MTI. As we approach this question about moving the low end height requirement to 17 inches, we're of course troubled by the technical challenges that we've already identified over our many years of experience launching 8 models that are currently compliant to the existing M302 design standard released by this body in 2017. But we're much more deeply troubled by the misapplication of the statistical data that's been used to justify the need to move the height to 17 inches. Today, I want to discuss the application of the updated Souza study and suggest a better way to find our path forward. In the summary of the final report of the cited study, it claims that 42% of wheelchair users would be excluded if the lower height limit for adjustable transfer services were set at 19 inches. Now that's been updated to 39%. We believe this assertion that no persons in wheelchairs have the ability to transfer to a surface higher up than the lowest measured point of the wheelchair is a huge assumption. And it's not backed by evidence from any study, but it seems to be the backbone of the justification to move to force the MDE height down to 17 inches. In fact, there is ample evidence that suggests that this assumption cannot be entirely true. I asked a local professor at the University of Utah with a PhD in management science with special emphasis on applied statistics to provide an assessment of the Souza study. And I'll later include his letter along with my written commentary that I wish to be a part of the public record. Among other observations, he wrote, while the Souza analysis seems like a reasonable attempt to make estimates when considering those who use powered versus manual wheelchairs, there does not seem to be sufficient evidence to substantiate the claim in the summary that any particular percentage of the population would be excluded from transferring onto any particular height. The ability to transfer from one surface height to another involves many assumptions regarding individual abilities and methods, as well as the equipment characteristics such as upholstery thickness that are not accounted for in this analysis. His report only considers wheelchair heights and does not include the mechanics of and human element of the transfer experience. A meaningful conclusion could only be supported by additional, newer data on the experience of actual patients with disabilities transferring onto various surfaces, and close quote. If we apply this assumption to America's toilet seats, then it's easier to understand and see the flaws in this assumption. If an individual in a wheelchair approached an ADA compliant toilet seat and transferred downward onto that surface, that lower surface from their higher up wheelchair, then the Souza assumption assumes that he would not be able to transfer back to his wheelchair because he cannot transfer to a higher surface. But we know this is not the case. Individuals with disabilities do this every day. How can we assume that 100% of all wheelchair users would be excluded, to use his word, from transferring to MDE of any height unless we study the mechanics of how actual patients transfer themselves? I challenge the general notion that wheelchair height must be equal to or higher than the uncompressed transfer height to be able to transfer. And I would ask this body to act on the original advisory committee's conclusions from 2017, that the data from the study does not apply to the height question at hand, that the board should initiate a brief study that reflects the direct feedback from a random sampling of actual patients with disabilities. I believe that the voice of the patients with disabilities must be heard, and it's the only data that we need to understand whether the current 17 to 19-inch height requirement needs to be modified. Why ask the wheelchairs from 1994 to decide the height of our MDE today? We need to capture the statistical voice of those individuals who will benefit from these regulations. Thank you for the time to express my thoughts and expertise in the matter.
Thank you for your comment. Okay, we're going to move to the next commenter, and that's Darren Walters. Darren Walters, if you're available, you can go ahead.
Yes, I'm here. Thank you. Good afternoon. My name is Darren Walters. I'm the Director of Engineering for MTI. We design and manufacture medical diagnostic equipment in the form of exam room chairs. Our company has placed intense focus in recent years developing equipment that would meet the needs of patients with disabilities in all aspects of the product's use. This includes considerations such as patient transfer, patient support, ergonomic effectiveness for both a patient and practitioner, pinch hazards, and practitioner access to the patient. In so doing, it became clear that there exist immutable physical trade-offs when reducing equipment transfer height, which potentially diminish the overall effectiveness and safety of the equipment. A slightly lower transfer height results in a significantly lower fully extended height. For example, in a 3-stage telescoping lift, reducing its collapsed height 2 inches results in a 6-inch reduction in maximum extended height. This represents a 3x magnification loss in extended height. In other words, on a chair with a low entry height of 19 inches that extends to 39 inches high, if its low entry height were reduced to 17 inches, it would now extend to only 33 inches high. This is the height of our seat today is collapsed height is 18 3/4. We already get complaints that our 39-inch maximum height is too low. In a scissor lift mechanism, another method used to lift exam chairs, there's generally a more dramatic loss effect at the raised position, typically 6x magnification or greater. Caregivers who are required to stand to perform certain procedures need the chair to raise to at least 40 inches high. Bending over while performing such procedures can lead to clinician injury and potentially poorer quality of care for all patients. Adjustments can be made in the breadth of the chair base to help lessen those losses. However, this results in a trade-off of physician access to the patient. For example, ENT and ophthalmology professionals are required to physically position themselves as close as possible to the patient to effectively diagnose and treat them. A large, bulky base precludes this ability to treat effectively. A large base also physically prohibits the ability to rapidly move a patient into a potentially life-saving Trendelenburg position without first having to raise the seat height of the patient. This leads to confusion by the practitioner at a critical moment of treatment and a potentially life-threatening situation for the patient. Similar trade-offs come into effect with pinch hazards, urban ergonomics, and stability. Many exam chairs include a footrest for the patient while the chair is raised. Lowering the transfer height necessitates reducing the distance from the seat to the footrest, meaning the knees of taller patients would extend far above the surface of the seat. Picture a tall person sitting on a small child's chair with his chin nearly touching his knees. Design efforts can and have been made to make this distance adjustable. However, this ability is again limited by the telescoping loss effect described earlier. Thus, the lower the transfer height becomes, the less ability there is to adjust length, meaning a far less ergonomic experience for most patients. In my professional opinion, lowering the minimum entry height to 17 inches would force manufacturers to reduce the ergonomics, safety, and effectiveness of their equipment to comply with this standard. It would alter diagnostically required operational characteristics of the equipment and would lessen the use of the equipment for its intended diagnostic purposes. MTI has accumulated a wealth of knowledge over the past 12 years in developing products to meet these requirements, and we will elaborate further in written commentary submitted later this month. MTI would also welcome the opportunity to provide further evidence of these concerns to decision makers in a setting that would provide more time to address these critical matters. Thank you for your time.
Thank you for your comment. So let's move on to the next commenter. And the next one is Brad Baker. Brad Baker, if you're available, you can go ahead.
Can you hear me?
Yes, we can hear you fine.
Okay, thank you. Good afternoon. My name is Brad Baker. I am the president of MTI. As many of you may know, our CEO, Jeff Baker, and our company has been active members of the Access Board Advisory Committee for many years and have been part of decisions made by the board. We've spent thousands of FTE hours designing and millions of dollars developing equipment that fulfills the purpose of this body to make medical diagnostic equipment accessible to patients with disabilities. We believe we are the only company that has released products that are fully compliant with the M302 standards today, including this height requirement in question. To date, meeting the current standard has increased costs depending on the product from 16.5% to slightly over 47%. During committee meetings, we evaluated the data from the University of Buffalo Center study regarding wheelchair heights and conclude that this data from 1994 could not be used to describe the patient experience and adequacy of a transfer surface height, and it should not be used to inform the board's decision on a transfer surface height. We decided that a new focus study must be commenced that captured and represented the experience of actual patients with disabilities as they transfer onto surfaces of various heights using various methods. We're concerned to learn that despite our direction years ago, we find ourselves trying to make the same decision based on the same information we already decided was not accurate or adequate. The study measured from under the person's posterior while seated in a compressed cushion in their wheelchair to the floor. Yet the regulation requires that the transfer surface is to be measured in uncompressed height. Please consider the futility of an attempt to transfer yourself onto another surface without removing all or most of your body weight out of a compressed cushion. The data also doesn't consider how many of these patients with disabilities stand up to transfer or use boards or other devices to transfer. It suggests that the patients transfer from the rear of the wheelchair, yet this is also impossible to do. The study also suggests that the surface heights must be equal for a successful transfer to take place, which we believe is proven to be not to be true with the height of ADA compliant toilet seats, which is also 17 and 19 inches. Today, we are also being asked what it would cost to reduce the entry height down to 17 inches, even if it was possible without making the equipment unusable for diagnosis. This would take several years to accomplish and likely costs an additional 20 to 30% more to the already struggling healthcare system. However, our biggest concern is that the compliance to 17 inches would alter diagnostically required structural and operational characteristics of the equipment and would prevent the use of the equipment for the intended diagnostic purpose. Doing this would affect all patients and caregivers, and all would suffer from the required changes to the equipment. Caregivers would suffer from these required equipment changes due to restricted access to all patients, bending over and stooping and needing to manually adjust the equipment. The 2018 survey of occupational injuries and illness suggests that healthcare workers are the most likely to be injured for non-fatal occupational injuries. Healthcare workers and patients need diagnostic equipment that considers their ergonomics, access, safety, and ease of use to ensure safe and effective patient care for everyone. I'll submit some more further commentary in the coming days. I want to thank you for your time and consideration with these issues.
And we want to thank you for your comment as well. Okay, so we have one more comment. I'm not sure if they are available, but Ted Tacova, if Ted Tacova is available, you can speak. Okay. All right, so we're going to move forward with some other comments. So we have another comment of if Dr. De Souza is still available.
So, Bobby, if it's okay, could I make a brief comment or response?
Sure.
So I appreciate the feedback and the comments. I think we do know that there are many factors that affect the ability of people to transfer in and out of their wheelchair to a different seat. This analysis was, again, based purely on the static anthropometry. In the opening paragraph of my report that's online, I think we were working with the assumption that a level transfer would make it offer the highest, I guess, ease in a successful transfer that is quick, that is safe, and efficient in terms of energy expenditure. In our study, we did not measure changes or the differential in seat height. And so we were working off this simple assumption. That being said, other studies have been conducted looking at the ability of people to transfer between unequal seat height, transfer heights. My colleagues at the University at Pittsburgh, the Human Engineering Research Lab, HERL, have conducted and published 2 other reports on studies funded by the Access Board on this exact same topic, looking at height differentials, looking at horizontal gaps, looking at different configurations, setups, so orientations during the transfer. So all of these have been studied. Of course, those studies involve smaller samples, which again would then face the questions about the representativeness of the sample. So I think every study that we might look at is going to have some assumptions, is going to have some trade-offs made in terms of study design. And that's just, I think, a inherent aspect of science, right? There's no perfect study. So I hope that all of these studies, including the analysis that we've done, but also the other studies that are published, I think, on the Access Board site. If not, I'm happy to provide links here to the Human Engineering Research Lab's website with the reports that show the effects of how challenging and difficult it can be when you have these kinds of height differentials, right? So particularly height differentials greater than plus or minus 1 inch from the wheelchair.
Oh, thank you for that, Dr. De Souza. Okay, so moving forward, I know, Dr. De Souza, one other piece, we talked about this before. It's not really in terms of, one question was about, do you have a recommendation for the low height that would be mandated? And I know in the study, you're just basically reporting the findings. It's not really showing talking about what you actually recommend. It's just talking about the findings of the actual study. But that was a question that was out there as well.
That is correct. I think I'm only trying to show the potential impact, one value over the other. I do not advocate for one value or the other. This is only about the pros and cons, right?
Yes. Yes.
The other part, I think, is the resampling, looking at the different hypothetical scenarios. The wheelchairs still are modern devices, right? From the last decade or so, right? Only the percentages that were from the 1994, 97. And so those percentages, we could look at even additional scenarios that the board might be interested in using our current data, right? And so this is, again, just to show the usefulness of this resampling methodology in trying to analyze these hypothetical or what if scenarios, right? And ideally, you want to look at different scenarios of different percentages to come up with a value that is somewhat robust to potential changes in the future, right? Or demographic changes in the future.
Thank you for that, that clarification. So I just want to remind everyone that if you do have questions, if you want to provide public comment, to make sure to put your information in the Q&A on the platform here. And let me just pull up and see if we have some additional questions. Okay. So one question that we have here is, or one comment, excuse me, is what if instead of redesigning the exam tables, an elevating platform could be placed next to the exam table? The wheelchair goes onto the platform, raises to the needed level, the patient transfers, and the platform is moved with the wheelchair out of the way.
We thank the commenter for that comment.
Thank you for, yep. All right, and like I said before, if you have any questions, if you want to provide public comment, please enter your information in the Q&A. And so, and we'll be happy to listen to your comment. But I think kind of going for what we talked about already, one of the things that when we talked about this request for information that the Access Board is particularly interested in, we're looking at not only just the low height of adjustable MDE products currently on the market. It would be good to hear from manufacturers or people who, it was good to hear from them to see what's out there currently on the market and what is, what's out there right now and what's in use. So we have a really good idea of what the market is saying as well with that. And then from 2017 to where we are right now, there's been so many different changes and innovations in medical equipment and devices and design. And it's just important to bring that information as well. That would be helpful to note as well. So any information that you have, we'd be happy to hear from you as well.
Bobby, can you hear me?
Yep.
This is Brad Baker again with MTI. Just a little history after when we were part of the Access Board and the decision came out, we are working towards access, lowering the heights based off of other recommendations from other government entities in the 17 to 19 inches, which is primarily came from toilets. We spent about 6 years doing that, and we were able to accomplish an 18.75 inch entry height. And that's the best we were able to get our entry height as low as we could get it when we tried for those 6 years, and still providing the other needed characteristics of the equipment. So to kind of let you know where we are, we're just under 19 inches.
Just under 19.
Yep.
All right, thank you for your comment. Okay, so let's see here. So let's see, we have another comment here. Okay, so it says, after a decision was made in 2017 on the inadequacy of this original study to answer the low transfer height question, it was our expectation that the Access Board would commission a study comparable to many other physiological tests of the original study that would understand the patient experience when physically transferring between various seat heights, using various methods to guide us to a recommended height, excuse me. And then it asked, was there a follow-up study of this nature conducted according to this expectation? And right now, we do not have another study that is funded from the Access Board at this time. That may be something that we may look at in the future, but right now, the Access Board, there's no other study that we have any funding for that at this time. And thank you for that comment. So I see another one here, and this might be under the same thing, Dr. D'Souza, if you're still available. So this question is really about giving the different studies. Would the 18-inch minimum achieve the maximum result given the investment required? That really, I don't know if that really is something you can really answer, but you can speak to it if you'd like, Dr. D'Souza.
Sure. So I think one thing that is evident, at least from the present analysis, that there's benefit in going lower, right? So that you would at least have to capture a larger proportion of a wheelchair population in terms of a level transfer, right? With the assumption that level transfer being easier. But there's also like diminishing returns, right? The further you go into the tails of the distribution, you're starting to benefit fewer and fewer people. It is not my position to know where or to say where to draw the line, right? I think that should be a consensus decision. All I'm trying to show is, at least from our static analysis of just occupied seat height, with a fairly large sample, we still have a large group of people that we measured. I'm just trying to convey here what that diminishing returns or what that cost function might look like, right? And so we can compare in these, at least in the three scenarios I presented, between 17, 18, and 19 inches. And hopefully it, I think, gives everyone an idea about what that function in terms of diminishing returns might be, the lower we get, right? So would 18 inches be a suitable, adequate compromise? Hard to say. I think it depends on which variables we're talking about. We're going to look at the, the cost, the technical feasibility, and also the net benefit, right? Which is what the piece that I'm trying to contribute here is what is the proportion in terms of the net benefit in going from 19 to 18? How many more, what percentage of people might be benefit more with that additional 1 or 2 inches increase in adjustability? So I do not have a direct answer, but I hope that at least what I'm presenting is one piece of that final answer.
No, thank you for that. I appreciate you saying that. Okay, so what we're going to do now is that we're going to open this up, and if you have any comment, well, before we even get to if you have any comments, let's just talk about where written comments. So if you have comments and you haven't, you think about it later, you have up until May 27th, and you can submit your comments or written comments via email to MDE at access-board.gov. That's access-board.gov. And so you have, like I said, you have up until May 27 for written comments as well. All right, so I'm gonna go ahead and leave it open for just a minute to see if we have any other public comments, and then we'll go ahead and move forward with ending today's session, today's meeting. Now, also what I want to know is that if you have any questions about the study or any questions related to medical diagnostic equipment, you can email that same email at mde@access-board.gov as well. And Dr. De Souza, I don't know if you have any final comments you would like to say.
Bobby, we do have someone in the comment chat that has asked to talk. Kathleen Collins.
Oh, good.
Kathleen, you should be able to unmute yourself now.
Okay. Yes, I'm
There you
unmuted. Thank you. Hi, my name is Kathleen Collins. I'm a member of Downstate New York ADAPT and also on the board of Disabled in Action in Metropolitan New York. And I have to admit, I haven't read through the entire regulation, but what I've been hearing today is about issues about inches and how many people it will affect and how many people it will affect. But I know personally that every inch does matter to people when you're going for a medical treatment. And I know myself from my own history, I'm a quadruple amputee. And I know when I first started out having my mammograms, I had to go from my wheelchair, which is low down, onto a chair that they would hike up higher for me just to do the scanning of my breast. And now they have machines that go down a lot lower. I still have to hike my body up a little bit to reach it, but I really would appreciate it if, and I think others would, if we made machines that gave people more choices. I mean, not everybody is 5'8" or 6'2", and we're all different sizes and shapes, and we all have different capabilities of even transferring from a chair or hiking ourselves up. I'm still in pretty good shape, but I am getting older, and I don't know, 5 years from now, whether I'll be able to pull up on my lower stumps to reach that little bit of space that I have to reach to be able to have my breast examined. And so I really do appreciate when machines are made so that everyone can use them. And I just would really appreciate you thinking about that and about thinking about choices, and not just for people who use wheelchairs, but for other disabilities too. Those with low vision or who are blind, those who have hearing loss or who are deaf, those who have cognitive disabilities, those who have sensitivity disabilities to chemical sensitivities. These are all different types of disabilities, and I'm sorry if I haven't thought of one here, but there are so many disabilities out there, and we're all different. Everybody's different. Even people who are able-bodied, I'm sure appreciate if you're a shorter person, a shorter woman, I'm sure appreciate having the machine come down lower for them. And I know maybe somebody that's tall maybe needs it up higher because maybe they're on crutches and they can't sit down when they're in a place. I don't know. So we need to think about everyone and all options. That's what I'm just saying. And we will put in further comments once I review the regulations. Thank you.
Well, thank you for your comment as well. Okay, we're going to leave it open just for a few more minutes. If there's any other comments, please enter that information into the Q&A. Okay, so it looks like we have Darren Walters. Darren Walters, you want to speak?
Yes, thank you. I appreciate it, Bobby. I just wanted to take another minute if I could. I appreciated that last commenters. Can you hear me okay?
Yes, we can. Yep, you can go ahead.
Sorry, there, we had to get the audio working there. You can hear me okay?
Yep, you're okay.
Just wanted to, I appreciated that last commenter's comments and wanted to maybe elaborate a little bit more on some of the trade-offs that exist that we were looking at. Like I said, we put a lot of time and attention to this and really made a tremendous effort to meet the needs of everyone, certainly those that deal with disabilities, all shapes and sizes of people, and there's certainly some trade-offs that go into that. And designing all this, we put a lot of effort into designing ADA compliant equipment here recently. So some of the trade-offs that come into play with the lower rate or lowering that transfer height with regards to the footrest, for example. A lot of particularly M302 type equipment has a footrest. And so if you lower the seat to 17 inches, you're automatically forced to raise the footrest for pinch hazards and other obvious reasons, some amount above the floor. So a 17-inch seat height means maybe a 15-inch or less distance between the seat cushion and the footrest. And that distance is far too small to be comfortable for most patients. This is particularly of concern with patients that need their legs supported in order to keep them from falling into a vulnerable spread position. I know there's a lot of people with disabilities who have that concern that their legs aren't supported. Our chairs actually in their development, they now allow for some expansion of that distance as the chair raises. But if you shorten that span, so where we're at the 18.75, if we shorten that another 2 inches, let's say, that capacity to adjust gets shortened by an additional 2 inches, meaning when we're fully extended, it's 4 inches shorter than it otherwise would be. That shorter 4 inches also plays into the length of the chair when it's laid flat. So if you lay the chair flat, instead of being 2 inches, just 2 inches shorter, it's 4 inches shorter due to the telescoping effect that I talked about a little earlier of the seat height. So there's a lot of trade-off considerations that come into play that are affected directly by reducing that height. And they all affect ergonomics, safety, and effectiveness of the equipment. So I just wanted to make it clear that, you know, these small adjustments at the lower end, when we're talking about inches and things, little adjustments there have magnified effects at the opposite end, especially in raising the chair, where we're talking about gaining 2 inches down at the lower end, you're losing 6 inches at the upper end. So I also, maybe it's worth pointing out that thus far as we are aware, we're the only company that has accomplished or arrived within the standards as they exist today. So sorry, I should clarify, in the M302 type equipment. Thank you, Bobby.
Well, thank you for your public comment as well. Okay, so we're going to just leave it open for another minute. If there's any other people who would like to comment, please put your information in the Q&A. Otherwise, we can go ahead and move forward with ending today's informational meeting. All right, so we'll go ahead and we'll end today's informational meeting. We really want to thank you for joining us today. And just to let you know that this event has been recorded, and the recording will be available on the Access Board's homepage and its YouTube channel as well. We want to thank the presenter and everyone who participated in today's event. Thank you, and have a good day.
And this is Rosemary.